Welcome everybody to the video webinar series. Today we have Expected for Copilot on the agenda. Why Copilot struggles with specialized knowledge and how to fix it. Very exciting topic for today. And let's see what we have in store for you. I've been accompanied by two very smart and bright people. They will do a short intro when we get to them. So I just don't want to waste time and really dive into the topic itself. What are you going to learn today? Expected for Copilot. What is it? What is the architecture? What is the core concept actually? What are understanding the whole background and the thinking about it? And yeah, more importantly, maybe on a business level, recognize the strategic importance and moving towards practical use cases. Some housekeeping rules. This webinar is being recorded and will be shared with all the registered people. And if you do have questions, feel free to make it interactive through chat. We will be monitoring the chat and will be answering all your questions. Once again, Rikkert, let's dive into your screen right away and don't waste time. Because I think you have quite some stuff to show.
Exactly. Thank you, Ruud. Okay, so thank you all. I'm Rikkert Engels. I'm the founder of Xilio and also the founder of Expected, the new spin-off. So what is the story?
Rikkert, hold on. You are sharing the Teams screen and not your the presentation.
Good. So what is the story of Expected? The story of Expected is, let me start here. The story of Expected is that Jorn, who will present it in a second, called me up on a Tuesday evening, September 2024, on 9 o'clock in the evening, saying like, I think I have something really, really cool, and it doesn't exist yet. So he explained it, and we immediately knew like, okay, this is massive. This is massive. And Jorn will explain the whole concept behind it, but that's how it started. And then in September 2024, we formed a team and tested our thesis if this was really better. And now with a team of 12 and 18 months further, it's live for production. And we have a working solution here that I think is revolutionary to solve one of the biggest problems we currently see in AI, and that is that the wrong document is used to create an answer, and that leads to hallucination, and that leads to a huge problem. And so what we're seeing happening right now in the market is that Microsoft Copilot, of course, is a massive success from a marketing point of view and from a rollout point of view, but from the people that are using it, from the people that are buying a license, 36% is actually actively using it. So the adoption of Microsoft Copilot stalls because people are disappointed with the actual results. And why do they leave? They leave because the answers disappoint. Are you asking a question and you simply are not getting the answer that you want? And the instinct is to blame the AI. If you go to any AI conference, you hear it all the time. Copilot uses the old models. Copilot uses the wrong models. Copilot is not on Claude, etc. And then Microsoft announced that now we're on Claude and it solves the whole issue. But it's the wrong diagnosis. The real problem underneath it is that Copilot works on the data in your Microsoft tenant, and it first needs to retrieve the right information before it passes it to the LLM, and that's where the real problem is. So, is it really a model problem? No, or does it simply not find the right document to provide the answer needed? Because of course, if the model receives the wrong source information, it can never create the right answer. It only works with the information it's fed, and based on that information, it is creating a model. So fix the retrieval, you most likely fix the outcome as well. Now, what is our experience as doing 22 years of Xilio migrations? Roughly speaking, we've been existing for 22 years. On average, we perform roughly 50 migrations per year. On average, every migration has 30 to 40% of duplicate information in their current system before they migrated to their pristine SharePoint environment. And roughly everybody mentions the topic like, should we not clean our house before we migrate it into our pristine, into our new SharePoint environment? And literally nobody did it. We once did a migration at a large American bank, and they had 300 terabytes of information from employees that were no longer working for that bank for a year. They spent $600,000 in SharePoint storage cost for employees that no longer worked for the company. I would think that would be the easiest business case to save $600,000 per year. Yet nobody did it. So even they didn't dare to pull the plug to pull the plug there. And so we stopped trying to make cleaning happen. We made it unnecessary. That's the big thing that we make possible. And because what is the reason people need to clean? And I'm going to explain this in more technical detail soon. The reason people need to clean so that the polluted information does not pollute the answer. Polluted information pollutes the answer. Polluting answer that gets to a LLM gives a polluted response, and as a result, it doesn't work. It is as simple. Now, I'm going to show you two use cases. Or I'm going to show you one use case, and Jorn is going to show the second use case. The first use case is basically explaining the general concept and how we can sort that out so that that's a ROT data, irrelevant data, simply doesn't pop up in the index. So what we are doing is that we change the index. We don't clean. We simply make sure that polluted information doesn't pollute the index. And if polluted information doesn't pollute the index, there's no pollution to the LLM. It's as simple as that. So that's the first use case, I think a very important use case. And then Jorn will get deeper, because with our new technology, we can not only, let's say, avoid the cleaning, but we can also go a level deeper in the answering. We can also provide more accurate, more rich answers so that Copilot can actually really function as it is promised to us. Now, demo time. Let me show you how it works. This is a demo environment, and I'm just going to explain to you the principle. It is relatively technical, but I have no other way to explain it as to go a little bit technical here. And but I'll try to make it short. So in essence, Copilot works on many things, but at the heart of Copilot is a semantic index, and at the heart of a semantic index is a vector search. Now, they built 1,000 things around it, like context rec, and they know who it is, they know what you've done, they know what you've emailed, they know everything about you. But if you do a search, it goes to a vector index. It's the core of every retrieval augmented generation pipeline today. Why is it the core? Because it was the best available in the market. So there was nothing better available. And so how does a vector index works? It looks for a set amount of nearest similar sounding documents. So it works on similarity first. Let's say I have 1 million files or I have 100,000 files, and I'm looking for a company update presentation. Then it looks for similar words regarding company update. And it takes then the top 30, 25, 50, something like that. It cannot be too big, because then it will be very slow. But you need to overshoot, because I need to do step 3, which is I need to filter on the constraints that are provided. I need critical tickets, I need the latest company update, I need the correct company update, I need the last one that I gave. There are constraints that are part of the query that need to be respected, and these constraints, they have to be included in the results. So in essence, how a vector index works is that you have a similarity score for the top 30 typically, and then you do a constraint list. You filter on the metadata provided so that you narrow it down to the top 3 results, and those 3 results are provided to are then re-ranked to get the right answer, and then that answer is provided to the LLM, and that works then to the next phase, and it provides the answer to you in the Copilot environment. So this is the generic principle. Now let me explain the generic principle, how we are different to this setup and how we are potentially better there. Now, what I'm having here, I start with a very easy use case. I want invoices from Acme. I see that here. Then on the left here, I have a single vector search, just to explain the principle that a vector search works on meaning. So what I see here, in my top 3 list, I have all invoices, but one is from Umbrella and the other 2 are from Acme. Now, so what do I do in order to show it from the right client? I add a filter and a re-ranker. So that's the typical process. So that is, then I have a filter and re-ranker. So what I show an invoice from Acme. So I filter on client Acme. And then I show the invoice from Acme and it's all correct. Now, then there are several things you can do. You can do post-filter, pre-filter, but the essence is always the same. What Aspected does is we do it differently. We are, and I showed already here, we do not include a filter. We take every aspect of that query into a single query to the index that we created based on the aspects. So we rate it on words, meaning, type, client, amount, and date. And that's how we build up the score. Now, for an easy question, there's no difference. But if I go to a different use case, and this is a live use case that is live at Agfa. This is 250,000 support tickets. And in these support tickets, I'm going to ask for critical access tickets opened overnight. Now, what I see here on the similarity, it cannot find it because it cannot rate on critical, so it's not the right one. But what I see here on the right, on the typical setup with vector, filter, re-rank, I see that the first hit is cannot access my account, scores 0.99, which is very, very, very similar to the question asked. Number 2, 99. Number 3, 99. Number 4, 99, etc., 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 etc. Spoiler alert, the right one was a number 61. 61 was the one that was truly critical. All the others were not critical, but they all scored 99 on meaning, so there was no way, or it was pure luck, you could almost call it luck, that none of them was critical, so nothing was retrieved. So in this scenario, it was not the right filter or the right critical access ticket was not retrieved. Now, let's look at Aspected, how we sort that. At Aspected, let me first show you the tickets. There were 3 tickets. SSO login failures for all users, it scored in our scoring 87. Account lockout storm overnight, it scored 86. Permission denied on shared drive, it scored 72. Now let's look on what we are seeing here. What I'm seeing here is that indeed the number 1 score in our index was indeed only 95 on the topic itself. Still very meaningful, and still very similar as the question, but not as similar as the other 52 that were ahead of this. It scored a 95. But we also include priority, status, and created as our score. Priority was 1, status was not included, so we counted as half. Created a 1. So the overall score was an 87, because we included priority and created in our scoring mechanism. That is the fundamental element. Let's go to a second ticket here to explain the concept. The topic was 94, so it was less similar, but priority and created still scored a 1. Now, let's go to a third one. The topic was scored here at 95, but it was not created overnight. So at created, it only scored 0.33. So what we're doing here is we're giving a very fine-grained results how the scoring mechanism is created, which is essential, and based on that we retrieve the right information. So the hard cut, which is part of a vector filter of a vector database, this hard cut, which is the fundamental flaw of enterprise AI, we have solved that here. That's why we're so excited about it. Now let's go one step further. Let's take another example. This is confidential data breach incident reports from the German office 2023. I'm looking for that. Now, on the vector, filter, and re-ranker, it says none of the retrieved records fully match your query. The closest is the German breach email thread because it's 2023, but it's an email. It's not a report. The other one from 2023 is the Dutch office. So I show the Dutch office. I show some information, but it's not correct. if I base my second step on this, it will go horribly wrong. Now let's look at aspected. What we do here is that we also say none of the retrieved records fully match your query. The closest, though, is the DE Office Data Breach Incident Report, which is an incident report, but it's from 2022, which covers a data breach at the German office, but it's from 2022, not 2023. The Dutch Office Data Breach Incident Report matches the year and classification, but covers the Dutch office, not the German one. The breach response policy is from the correct year and region, but it is a policy document rather than an incident report. And here it gets really, really interesting, because what we see here is that the number one scores, because it scores 93 on meaning, 1 on document type, 1 on region, 1 on department, 1 on classification. But the year scored 0.6. But because the other scores were so high, it showed up as number 1 on the list. If I go as the number 2 on the list, you see that the region is not correct, 0.3. That's why it's number 2 on the list. And if I go to the number 3 on the list, you see that the document type is not correct, and the department's not correct, but the rest is actually correct. So what this gives you is full visibility into why certain information pops up as the number 1. And here there is simply all the information I have is that it scores a 9.7. That's it. There's no other information available here that gives me any possibility to do anything with it. Now let's go back to what is the consequence of this. So the consequence of this is, let's take the average debug cycle within an organization. How does debugging work? The first step of a debug cycle is reproduce, second step inspect, then diagnose, then fix, then verify. This has been true for years and years and years, and this will be true for many, many years to go. And so this is how a developer fixes a bug. Now, what is the current status of debugging? So let's say I am a developer in Copilot, and my support team tells me that the support tickets in SharePoint are not popping up in the right way, and I need to fix it. Okay. So what does the developer do? They reproduce the query, they inspect the results, they read the results, and they find first 50 all scored 99 on meaning, only 61 on meaning is critical, because they can just look through the scores and they can find that. What is a diagnose? Okay, we have to move critical up the ladder, because it didn't make the cut, so I need to move it up the ladder. I can also expand the reach, but that will probably be a one-off solution and not a continuous solution. So I need to diagnose, move the critical up the ladder. What can be the fix to that? Okay, option A, I prompt engineer it around it. Now, I know because this was a live use case at AGFA, they tried it, didn't work. There was no improvement. You could still not pop up the right information, which is not unusual because there are 250,000 support tickets. So there's a lot, and 30 is then a very small number. So there's no improvement. Option B, what's option B? What other tools does the developer has in his arsenal to fix it? Rebuild the RAG pipeline. Have better chunking, have even more expensive like enrichment and chunking, all the kind of stuff that costs you millions, and try again. Trial and error. If we rebuild the RAG pipeline, maybe it works. There's no improvement. Option C, this will be the most beautiful hack. Why does the word critical not appear? Because it simply was one word versus 50 other words. Now, how do we fix it? Let's add the word critical 50 times to every ticket. This could work. This could work. Is it a sustainable solution? Probably not, but it could work. It could work. And now, how would the debug cycle with aspected work? We reproduce the query, we inspect, we read the results, we first 50 all scored 99 on meaning, only 61 on meaning is critical. Ooh, what would be the diagnose? Criticality is not part of the index. What is the fix? Add aspect criticality to index, and it's solved. It's that simple. Criticality is not part of the index in a normal vector database. You add aspect as a criticality to the index, and it is included, and your problem is solved. Now, let's get to another use case, the use case which is the topic of the webinar. What is the problem? The problem is Copilot gives me the wrong answer. It's a very wide problem. So what does the developer have to do? They try to reproduce the query. They inspect it, and they indeed see accurate results did not make it to the top 25. The real answer didn't make it to the top 25. What is the diagnosis? The ROT data in my SharePoint pollutes the top 25 of results. If I take the example of our organization again, and Jorn will also show this soon, is that how many proposals do we have in our database? We are a company of 40 people. We have 90,000 files in SharePoint. It's not that much, but it's 25,000 files per person that we are storing in SharePoint, which is, no, 2,500 files per person that we're storing into SharePoint. Math is difficult, but it's not that much. But we have a lot of company information. We have a lot of company updates. We have a lot of proposals because we have existed for 22 years. So in the first analysis of the information that's popping up, it just looks for similarity. So if you have irrelevant information in your SharePoint, the top 25 is polluting your results. It might have maybe 3, 4 out of 25 that could be relevant, and only that then is added to your metadata, to your filter process to provide the right answers. So the diagnosis, make sure that your ROT data doesn't pop up my top 25 and the problem is solved. So how do I fix it? As an IT organization, I go back to the organization and say, clean up SharePoint. It's the only fix ever done. Does it work? I can't tell you, because to my knowledge, nobody has ever gotten to this stage. So that is because it is a fata morgana that people, or maybe someone has done it, but at least none of our 1,000 clients has ever taken the guts, has had the guts to actually do it. How would we solve this? Reproduce query, inspect accurate results, did not make it to the top 25. Diagnosis, ROT pollutes top 25 of results. Fix, add recency, file name, content type, created at, last modified, etc., etc., etc. Add every standard metadata field available in SharePoint as a index, as a ranking mechanism for your index. Solved. So it is as simple. Have we cleaned up SharePoint? No. We made it as simple that the metadata available is part of the index. So if you look for the latest, or if you look for the last, or if you look for recent, or if you look for something from 4 years ago, or if you look for something which was the definitive file, or if you look for a file name specific, if I look for company update, if I look for a file with the name company update, the file name is included in my search. So it goes automatically, rises to the equation because it scores 1.0 on file name, so it will outweigh the rest. If I look for recent, then the created at will provide information, and information from 2023 will not be even considered part of the index. So that is what we do. We don't delete, we simply make it disappear from the top 25 results, and as a result of that, the index doesn't have to, or it will never be given to the LLM to provide an answer, because it was never part of the index in the first place. That was of the results. So that is the principle of why we can improve the quality of your Copilot without a cleaning, because we simply hide it from the index results. So this is a good moment to hand it over to Jorn, because we also have a complex use case. Jorn, over to you.
Yeah, thank you for the handover.
And by the way, Jorn, thank you again for the brilliant idea of implementing this.
Thank you for making me actually implement it. So let me do a quick screen share. I think you should see Copilot Studio by now. So this is sort of the development interface for making Copilot agents. So on the right, we have the chat, for those that don't know. But let me first start with the data set that we are using for this demo. So what I did, I created a little demo environment, which has, if it shows, migration proposals. And there's these weird names in here, which are very normal for standard companies, I think, especially the parentheses 2 and the versions in there, and the many different versions to it. So what we have done some classification here to add the document type or the document type, the source system, the target system, the year when it was done, and when the client was there. This is, by the way, all fake data. So there's no actual names, or maybe there, but not intentional names in there. And so what we did is we have one setup where we've ingested everything through expected, and we have one where we just let Copilot connect to this data set. And what we can do is compare the results. And I think that's especially the interesting part. So what I can do is, for example, list all proposals to SharePoint Online. And so when we look in this, we have proposals, SharePoint Online. These are two aspects. So I can run this. Let me copy it because it saved me from typing. So what I can do here, run it as well. So it takes a second to answer. So what I can do is show here we have the proposals and we have the source system, right? So what we can see, it takes a while. So it's listing all, right? It's a larger operation. So what we can see here is it's loading. So what SharePoint is doing, and it's doing very confidently, it's giving us some proposals, right? There's 4 proposals here which it references, and it says, hey, there's also RFP responses. All these documents came up because there's probably also the text proposal in these documents, but it's not really classified as a proposal. When we look at expected, it's still running because it's finding a lot more documents. Let's see. It's always exciting to do a live demo. I don't think I sacrificed something for the demo gods. Maybe we can look at this result still because it's it's still trying to sort of find random documents, right? So it's not per se recent document. It's just finding some documents that talk about proposals and that are talking about SharePoint Online. So it's not really structured. So let's see. The response from expected is actually 23 proposals. All of these are actually pointing to proposals. So I think we can see. Let's see if I just open one of these. I mean, it's called Voorstel, proposal. So all of these documents are actual proposals. And so you see there's no, the confidence from Copilot is these are the documents, and it doesn't per se say there's many more because it just cuts off at some point. It just doesn't know there's more because of the whole cutover point, the similarity search. And so we are able to actually find all of them because in the full list of documents, we can actually find all the relevant ones. That's one of the use cases. We can also, for example, try a more complex one. So what we can do is ask about live link proposals to SharePoint Online from 2025. So these are four aspects. Let's type it in. Let's start a new session here as well. And fire it off. So let's see, and we can let this one run first. Maybe the other one's done as well. Ah, there we go. So what it starts with is, hey, there's not really any proposals for 2025. So no overconfidence, but it says, hey, there's actually one from 2024. And also it goes into detail like, hey, we also found some similar ones, but not the actual ones you were looking for. If we look here, I think it should reference this document. Let's see what the date is because it doesn't mention. Let's see, it's from 2023. It very confidently puts it at the top. I mean, in the end, it writes a little bit of a disclaimer here. Hey, 2025 is not really a thing. This one is the closest matching. But it overconfidently tells you so, right? So you have to really look at the response. I also mentioned it here. But this is really a big problem, right? Because you basically assume that it finds the documents, it finds the relevant documents for you. Yeah, I think that's really the demo I want to do. Maybe I can still do one last one. How are we on time? I think you're muted, Rikkert, but let me
absolutely. Go ahead. Yeah.
One more. So documentum to SharePoint proposals last year. So this is a recency relevant relative term, right? Last year is not really a thing. Let's also give it a shot here. And let's see. So it's searching through all the knowledge sources. Oh, last year. It thinks last year's 2024, which is interesting, but because I don't think that's true. And so it does find documents for 2024, but it's not really the right year. How are we doing here? So it says, hey, we're looking for 2025. Can't find them. This is correct. The dataset doesn't have 2025, but this really shows you that sort of the overconfidence from Copilot and not being able to filter on these individual aspects give you these strange results. Yeah, I guess that's it for the demo.
I'm muted. I think what we should add here, Jorn, is that we also can steer the construction of the answer, because we know what the fee is, we know what where the link to the proposal is, so we can also provide not only the accurate answer, but also the consistency in the answer, so that an agent in a follow-up step gets consistent input for the next step. Yep. Because as you can see, we are always giving the title, we're always giving the summary, we're always giving the fee, we always give the link to the proposal. So that is also then very consistent, and we can do that because we can turn everything into an aspect.
Yep. And so, of course, you can do some system prompting, but there's almost no system prompt happening here. The only thing we say is use aspected, and that's it. And then it's actually able to optimize the whole problem here for us.
Yeah. So I think to summarize what we have shown you here is a deeper level of debugging capability that current vector indices, especially Copilot Studio, simply does not have. And by opening up the black box into the retrieval mechanism, we can provide more visibility. And because we can provide more visibility, we can also provide more steerability to steer the answer in a certain direction. And because not only we provide the insights in what the score is of the documents that are retrieved, which of course is a debugging mechanism, but showing why certain documents were retrieved is also a control mechanism to make sure that it doesn't hallucinate, because you're suddenly in control here. And lastly, what it does is, because we can weigh the individual aspects on importance, it gives you another tool to fix what is retrieved at a certain question. So if we go back to the example about the 2023 report of the German incident report, it was ranked on incident, year, and region. Now, let's say it gives the wrong report. Then me as a debugger has two options. I can either change the weight up front in the index. So I say, no, year is always more important. So I set the criteria wrong here. I put more weight on the year compared to the type of the thing. Or I say, no, it's always about the report. The report is more important. Okay, then I change the weight. It's another tool that a debugger has in his arsenal to fix the retrieval. But what we can also do is we can change it on the MCP so that the MCP gets better instructions on the weight, so that the weight is going to be dynamically adjusted based on the question that is asked. So in summary, because we have the ability to add aspects to an index, we not only increase the accuracy of the first retrieval, but we also increase the ability to control what is retrieved in the first place. And control means debugging capability. Control means control over hallucination at the retrieval side. And control means more, let's say, more control about if it hallucinates in the first place. So I think we are very, very happy to announce it, and we look forward to the next steps. If there are any questions, please put them in the chat or reach out to us afterwards.
Thank you, Rikkert. Thank you, Jorn. Can you switch back to the presentation, or because we have one slide on the survey? Oh, I can also share, obviously. Yeah. Well, you had the opportunity already to put questions in chat. I haven't seen any, but I want to point to this slide. Feel free to leave us a comment, a survey about what was this webinar about? What did you think about it? Was it too fast? Was it too deep, too technical, or was it spot on? Let us know so that we can improve our webinars in the future. Yeah, that was it. If there are no more questions, and there aren't in chat, then I think we should leave it at this. Okay. Thank you for joining. Thank you for participating, and hope to see you next time. Bye-bye.